All right. Hi. I just wanted to do a quick video and do a quick rundown of the problems. So day 9, questions specifically 81 through 84. Yeah, 81 through 84. The keyword here is you have to do these algebraically. So I did a video in the previous posts. Um, I don't remember exactly what it was, but look at the previous post. There's like 3 videos. I did one. Mr. Clarkson did one. The one that I did is called question 79. Yeah, because 79 I did it on the computer and I also did it algebraically. Mr. Clarkson did a video and he also posted another video that he found on YouTube. All right, so 81 through 84 in that respect should be covered. 85 can be done using the calculator method, right? So there's no actual algebraic word that you have to do here, right? You could actually just go ahead and plug this into the calculator and get an answer. Um, yeah. All right. Question 86, all the way down, actually, to 89. These are literally just calculator questions, right? So take these, plug it into the calculator, find out where they meet, solution. Remember to do that, you hit second, and then calc, and then option number 5 is called intersect. So that's what you need to do to solve these problems. I'm just going to go ahead and erase these so this will be fresh. Question number 90 says do this algebraically. So this turns into an algebra 1 problem. And remember that in algebra 1 you learned that you set this. So negative 2x plus 1 equals negative 2x squared plus 3x plus 1. If you do this question on the graphing calculator, you will get an answer, but out of the 4 points for this question, you only get 1 out of 4, which I guess is better than nothing, but since this is an opportunity for us to learn, and this is a packet that you need to turn in, you need to actually do this algebraically. So remember, a key thing is move everything to one side. My suggestion would be to move everything to the right by doing plus 2x and negative 1, and then this cancels out. You're left with negative 2x squared plus 5x equals 0. And you should be able to take this from here using algebra 1. Remember to find the solutions. Once you get x, take it back in and plug it back in to get the y's. Number 10 is a question that you take, this into the calculator, plot it, and then see where they meet. This is very similar. Question number 93, you need to do this algebraically. So wherever you see the y, you're going to plug in x minus 28, and then solve that using algebra 1. 94 is very similar. 95 is knowing what these numbers mean in a table. 96, 97 are similar, right? For 97, you need to actually graph it on the axis below. Draw one on your paper and then submit a picture for this and find out where they meet. Use your Desmos calculator or your TI calculator or your Wabbit EMU calculator or your Calculate 84. You have a bunch of different ways to do this. 98, 99, 100, 101, 102, 103, 104, 105, 106, straight calculator, right? 107, you could even do this on the calculator by plugging all of this under y1, plugging this under y2, seeing where they're equal. I'm going to probably walk through this algebraically as well, but you should know how to do this algebraically. This one is translating this to math and then solving. This one you could do this straight using the formula that they give you and get the j by itself, basically is what it's telling you to do. If you have questions with that, let me know. This one, 110, same thing, right? y1, plug this under y2, see where they intersect. Remember always to check for an extraneous solution to see if it works. 111, same thing, plug it in, you can plug that into the calculator, solve. 112, same thing, plug that into the calculator. 113, same thing. This one you cannot, right? 114 you cannot, because it says to do it algebraically. So you need to take this whole thing. We notice that there's a 4 here, there's a 2x, and there's an x plus 1. So you need to multiply this whole thing by a 2 to get it to be a common denominator. So the least common denominator here is going to be 4x times x plus 1. So here now once you multiply this by 2, you get the 4x, and then you also have to multiply it by x plus 1. Remember, whatever you do to the bottom, you multiply to the top. You do to the top. So we're going to multiply this by x plus 1 as well. Here you have an x plus 1, but what's missing is the 4x, so you have to multiply the whole denominator by 4x, which means you have to multiply the whole top by 4x. And then here you have to multiply everything by an x and by an x plus 1 to get it to be 4x, x plus 1. And you do the same thing to the top, x plus 1. And then, yeah, once the denominators are the same, you can cancel them out because we have an equal sign, and then it turns into algebra 1. But actually do it. This question right here, again, you could plug this into the calculator, y1, y2 this, and then get solutions. Take each of the 4, plug them into the calculator, and see which one matches. All right, keep in mind that these two have i's, b and d, a and c do not. 116 is very similar to the other problem that we had with getting the j by itself. Try that. 117, again, you could y1, y2, right? 118, same thing. 119, same thing. And 120, you have to do it algebraically. So this is similar to the problem that I just walked you through, which was this one, 114. All right, so that's the whole packet. Try it, do your best. I will talk to you tomorrow on live to answer specific questions, but I want you to try these.